Ladies and gentlemen, distinguished guests, participants, I hope all of you had a good lunch. And so after this lunch session, we are into our session 3, supply chain build-up through collaboration and partnership. And in this session, we have speakers from NPCIL, from IEEE, from Walchand Nagar, and then in the session we will be having panelists, eminent panelists from DAE, ECIL, Walchand Nagar, and our international experts also. So, starting the first session of this, address of this session, I would like to request Shri Sunil Kumar sir, who is Associate Director, Maintenance and Outage Management at Nuclear Power Corporation. I would request him to please come on the dais and give his talk on insight on plant life management, renovation, modernization, and extension strategies for Indian nuclear power plants. He is an expert on this field, and we will be having a good insight on this subject from him. Sir, please welcome.
minutes के आसपास हो जाएगा. This is for forward and this is for reverse. Yeah, good afternoon, everybody. Dignitaries on the dais, colleagues and dear friends. My talk is in regard of insight on plant life management, renovation, modernization, and extension strategies for Indian nuclear power plants. Yeah, right. We see a tiger over here. It is in the side stage. And tiger is nothing but a replica of nuclear reactor only, you can say. So अभी इसने साइड स्टेज लिया हुआ है, अभी हमको इसको फ्रंट स्टेज में लाना है. तो नेक्स्ट प्रोग्राम में व्हाट आई विश इज दैट टाइगर का लोगो इधर रहेगा, एंड विद द न्यूक्लियर रिएक्टर्स, concrete pouring, every new reactor having a concrete pouring 1 year. So we are going to have a big leap in this nuclear technology and nuclear energy. With so much of experience in reactor operations, we are able to manage the increased life of the reactor operations. I'll skip some of the slides because they are repetitive. Our earlier friends have already deliberated. My presentation consists of about NPCIL, Indian electricity generation scenario, role of nuclear power in limiting CO2 emission, about pressurized heavy water reactors, plant life management, that includes surveillance, inspection, aging, and obsolescence, plant life extension, that is refurbishment of reactor, EMCCR, NMAS, coolant chalan replacement, EMFR, and EMBHR, boiler hairpin replacement and feeder replacement, then renovation and modernization. As we all know that NPCIL was formed on 17th September 1987 as PSE of DAE. It is fully owned by Government of India. Expertise in multiple reactor technologies, PHWR, LWR, AAA rated, profit making, large expansion plans based on indigenous PHWR and LWRs with foreign collaboration. The corporation was made only to indicate that commercial viability of the thing. So we are discussing that whether what is the cost of electricity, whether it is commercially viable. It is already proven. So there should not be any hitch in going ahead with our large scale expansion program. At the moment, we have got 22 reactors generating 6780 of megawatt. Reactors under construction, 10 reactors will be adding up to 8200 megawatt, including KAPP3, which is running at 50% of the capacity, 350 megawatt at the moment. And new reactors have been accorded sanction, 10 PHWR reactors contributing to 7000 megawatt. And sites, recently some sites have been approved for future reactors, 5 sites constituting 28 reactors. This is the history of the nuclear power reactors in operation. Tarapur 1-2, the oldest one. Then Rajasthan 1-6, Madras. They are dump tech type of moderator. Narora 1-2, first indigenous, we can say, standardized PHWR reactor. Then Kulam LWR reactor, Kakrapar 1-2, Kaiga 1-4, Tarapur 3-4, 540 megawatt reactors. Kaiga, we are having 5-6 also, and excavation has started at that site. Types of Indian nuclear power reactors in operation, that is Generation 1 BWR, Tarapur 1 and 2. PHWRs with dump tank and moderator dumping technology, Rajasthan 1-2 and Madras reactors. 220 megawatt PHWRs, NAPS, CAPS, Rajasthan 3-6, Kaiga 1-4. 540 megawatt PHWR, Tarapur 3 and 4. Then KKNP 1 and 2, 1000 megawatt Russian VVR reactors, and 700 megawatt reactor at KPP 3. We have got impeccable safety records. No incident of release of radioactivity beyond stipulated time in public domain in over 53 years of reactor operations, 577 reactor years of operation. And public dose is insignificant to the AERB limits and the natural background. You can see it is less than 1 to 2 MR per year to the public, where we say that even a flight from Delhi to Mumbai will give you 2 MR of dose in 2 hours. Here, even 1 MR dose is not getting to the public in 1 year of reactor operation. Then landmark achievements. Completion of 53 years of safe operation of Tarapur 1 and 2, oldest reactor in operation in the world today. Presently, both reactors are under shutdown for replacement of reactor recirculation loop and pressure vessel inspection. Then RAPS-2 has completed 41 years of safe operation. At the moment, hairpin replacement is under progress. MAPS-1 and MAPS-2 have completed 38 and 36 years of safe reactor operations. World record of continuous operation of 962 days by KGS-1, presently second highest among the world NPPs. At the moment, again, it is more than 440 days of operation, Kaiga-1. NAPS-2 operated continuously for 872 days. Because here it is on power refueling, we need not shut down the reactor for refueling purpose. And there is a mandatory requirement, biennial shutdown we have to take for surveillance and other as stipulated in the technical specification and as per the regulator. So we have to mandatorily shut down the operating reactor also for surveillance and inspection checks. RAPS-3 and RAPS-5 operated continuously for 777 and 765 days respectively. Continuous operation of NPCIL units for more than a year, 42 times so far. So our achievements, 21-22, we generated the highest million units, 47112 million units, highest generation so far, with a capacity factor of 87.59. And net profit by NPCIL was 6,000 crore plus, 6,800 or somewhere around. Plant load factor is very good compared to other renewable. Again, that India stand for COP26, reach 500 gigawatt of non-fossil energy capacity by 2030. This will lead to reduction in the total projected carbon emission by 1 billion tons from now to 2030. Our target is net zero emission by 2070. In an electricity generation scenario at the moment, nuclear contribution is around 2% maybe, and exactly we calculate it maybe 1.7%. This is as per the installed capacity. Then electricity demand projection. By 2041-42, it will be 3 times of the present, and even that peak demand will be again 3 times of the existing. So we have to grow in big way to meet the energy requirement. Again, if we see with the generation point of view, all India energy generation, nuclear goes around 3.4, double of the installed capacity. So our plant capacity factor is double of, in general, the average by any this thing. Source-wise likely gross generation in 26-27, this will grow to, nuclear will grow to 4% from the existing. The next 31-32, it will grow to 5% of the total, and coal is getting reduced at the same time. This is already explained that net carbon emission is, CO2 emission is very less in nuclear power plants compared to the lignite, coal, oil, and natural gas. Now I'll come to the pressurized heavy water reactors, which is the main, our fleet mode of plan. We have got power reactors with natural uranium. These are power reactors. I would like to point out one thing. At times we discuss about Fukushima, Chernobyl. Can it happen here with PHWR? Anybody? No, absolutely not. So these are inherent safe reactors, right? They are having natural uranium as a fuel, very low reactivity content. That is why we have to fuel it daily. They are all submerged in water, having calandria 140 tons of heavy water, having PHT 70 tons of heavy water. Again, the calandria is put in a box which is called calandria vault. It is again filled with water, light water. And emergency core cooling system, 30 ton of tanks, pushing water in case of emergency into the core in seconds, 30 seconds, 1 minute. So there are a lot of engineered safety features and inherent safety features into these reactors. Best fissile utilization per ton of mined uranium, heavy water moderated and cooled, channel type of reactor. There is some challenge in the heavy water cooled. Moderated is okay. Cooled means primary heat transport fluid. We are having heavy water, which is at 300 degrees Celsius temperature on an average and 100 bar pressure. And we open these boundaries daily. Reactor vessel, at this pressure and temperature, we open it daily, close it daily, and there is no leak. So this is what we have mastered in. And we are better than any international reactor so far this process is concerned. Our minimum target, whatever is there, we have achieved in Tarapur 3-4, 5 kgs of D2O collection through dryers for complete total reactor building. On an average, it may be 10 to 20 kg, whereas in any international similar reactor, it is 100 kgs of D2O collection through dryers in reactor building. And we have got minimum in Tarapur 3 and 4, it is 5 kg. So this is the way we are operating the reactor. Then channel type of concept, not a pressure vessel. On power bidirectional refueling, versatile for use of different types of fuels. We are at the moment we are using natural uranium 19 pencil. We can use slightly enriched uranium also in these reactors. This is the basic configuration. Here we have shown two steam generators. Actually it is 4. Then moderator is shown in blue color. It is for moderation, and cooling loop is shown. Then primary heat, pumps, circulation pumps, and steam generator. This is a typical figure of the calandria. These are the reactor channels, pressure tubes we call them. Then end fittings at the end, and 12 bundles in each channel. 306 channels for 220 megawatt reactors and 392 channels in 545 Tarapur type of reactor. And shields at the end. This is typical fueling, whatever we do on power refueling. Both the sides fueling machines are there, and daily fueling machines approach the channel and push 8 bundles and remove 8 spent fuel bundles. They are highly radioactive. In this fueling machine, nobody can approach to the area where spent fuel bundles are there. And that we are refueling since past 30-40 years. So anything going wrong in that fueling machine, we have to handle it remotely, and we are doing it. This is again primary containment, secondary containment, steam generators, calandria, fueling machines, suppression pool. Again, passive system. In case of accident, the steam will come down to the suppression pool and will get quenched. So passive system is always better. Then we come to the final thing. This is what our topic is: plant life management of nuclear power plants. Initially, it was envisaged that reactor core will be good enough for 20 years. Now you see we are operating for next 10 years, next 10 years, 30 years, 40 years. It is through that management only, life management, how we are doing it. The prime objective of the plant life management is to maintain safety, reliability, and production functions throughout the service life of a nuclear power plant. This entails preserving structures, system components, performance, and plant performance as a whole. It is required that the plant life management addresses aging issues, that is, system, structures, and component due to physical, chemical, nuclear, and biological processes, and obsolescence also at the same time. Maybe because of evolution of knowledge, technologies, change in requirement, codes, and standards. This understanding of aging is from the design stage itself. Development, optimization, and improvement of aging management program is a continuous process. Prevention and mitigation actions are there. Inspection, monitoring, and assessment of aging is there on regular basis. Then corrective actions are also taken for the same. In conceptual design itself, consideration is there for working environment, physical, chemical, nuclear, and biological conditions. Then equipment qualification of structures, systems, and components is there. Even in case of LOCA accident, loss of coolant accident, in the pump room, where it will go very humid and hot, the plant equipments, whatever, controls system, they have to be working. So equipments are to be qualified for EQ condition, environment condition of LOCA. Aging consideration during procurement phase. And aging considerations are during construction and commissioning also. Aging management program during the operation, we collect lot of data during reactor operation. Record keeping, that is PSI data, pre-service inspection data, in-service inspection data, then operating parameters, manufacturing data, continuous structure system components, reliability improvement program is there, health assessment and screening of structures is there. Relationship between aging management and maintenance program is established. Then component life evaluation is there. We have got a well-defined in-service inspection and reliability program. For reactor components, every 2 years of operation, we take a biennial shutdown, a shutdown for 30-40 days. We do BARCIS inspection. This is a system developed by BARC, that is channel inspection system. It will be inspecting for volumetric analysis, the thickness of the pressure tube, the gap between calendaria tube and pressure tube. So it will thoroughly take care of that pressure. This is a pressure tube concept, not a pressure vessel. And it is a thin pressure tube, maybe 4 mm thickness, which undergoes radiation, pressure, and temperature. So health monitoring is very important. Further, we do slivering also. We took out peel of the metal from ID of the reactor channel. We are scrapping the channel from the inside, and this has been established over 20 years. And Narora was the first reactor, and I was involved in that as a fuel handling man. We did it for the first time in Narora. We will put a tool into the reactor channel. It will first remove the oxide layer, which is a contaminated, then pure metal layer, and we will analyze that layer, that sample. It may be having a field of 20 to 30 R. We have to handle it, send it to BRC. They will analyze for hydrogen content in that. It will establish that process of hydrogen embrittlement does not lead to the failure of the pressure tube. So now this is a regular practice in every BSD. Our inspection team will ensure that 6 to 7 channels are done slivering, and we analyze that hydrogen content is well below that it leads to any hydride embrittlement of the. Then we carry out SAG inspection, SAG measurement, eddy current testing of the channel. Then annular gas monitoring system, which is a flow path. The CO2 gas acts as an insulator also between calendaria tube and pressure tube. At the same time, we monitor it for any moisture content. It will give pre-indication of any leakage from the pressure tube. During shutdown, we check a flow path, establish a flow path that flow of CO2 is taking place through this annular gas. Then we have got monitoring for steam generator, steam lines, feed path, ECT testing, thickness gauging, flow accelerated corrosion, then ECT of D2 heat exchangers, fuel handling system as a overall, we do inspections and testing, monitor PHT and shutdown system, primary containment control discharge system, fire protection system, process water system, and emergency diesel generators. Emergency diesel generators are, though they will be required in emergency only, but we do a testing on weekly basis. They have to be run without requirement also for say half an hour or so. We have got 3 diesel generator sets for each unit. So they will be regularly tested so that they are available during any emergency functions and requirements. Then we have a well-defined inspection and reliability program, civil structures important to safety. Evaluation is done with the SERC Chennai, turbine generators and its auxiliaries every 2 years. We involve OEM for the inspection and testing. And there are guidelines for maybe we are having a saturated steam type of thing because it is not a superheated. So LP turbine last stage blades are prone to. So we do inspection and short pinning at the desired interval. And there is a plan to replace the last stage blade of LP turbine also at given running hours. So mechanical equipment and components are also taken care during this period. Electrical system and components, C&I system and components. All NPPs have well-defined surveillance program for SSC important to the safety as per the technical specifications approved by AERB. We cannot deviate from any of the surveillance requirements as brought out in the technical specifications. If any surveillance is not done, it will require a condonation from the regulator. Then various degradation mechanism, what results into reduction in the life of the reactor core components. Thermal effects, irradiation is important. Then rest are well known. Pressure effects, steam, creep, fatigue, mechanical wear, fatigue, vibration, humidity, corrosion, erosion, hydride embrittlement. Then nodular corrosion is also important, what happened in Kakrapara 1 and 2. Abnormal rise in voltage frequency, insulation degradation in electrical systems. Based on the identified monitoring methodologies, mitigating measures fall under the following broad categories: repair, then replacement with a better quality components, enhanced surveillance requirement, testing for timely detection of incipient failures, calibration of instruments, improving the environment conditions, improving the design, change of material. So program that contributes to the aging management or life management of the nuclear power plants. The simplest is the preventive maintenance, PM. Then condition monitoring of the equipment. Then comes the in-service inspection. Surveillance testing, monitoring program as per tech spec and station policy. Component specific programs are there like reactor channel. Chemical program to reduce corrosion. We have got 1O performance indicators and they are monitoring the plant system health. So we were slightly lagging in 4 of the 1O performance indicators. That is chemistry parameter CPI, fuel reliability index, forced loss rate, FLR, and CRE, collective radiation exposure. In last 4-5 years, we have improved upon that and we are falling in CPI, almost we are getting 1 in most of the stations. And FRI is also almost established, but still we have to work on forced loss rate, that is unplanned plant shutdown. That we have to still work upon. The CRE is also within control. So operating procedures, control systems, feedback of the operating experience. We have got a regular operating experience sharing. Any event in the our domestic reactors, anywhere, international reactors, it is shared thoroughly and any corrective action required onto that is to be reported. Then spare parts and shelf management program. Probabilistic safety analysis. We have to submit PSA report to the regulator every 5 years of operation. Then they will give a clearance for further operation of the reactor. Renovation, modernization, life extension strategies of NPPs. As we discussed that nuclear power plants are capital cost intensive. This is already discussed and debated in detail. As we rightly said that time for execution, if we are able to cut down or reduce and bring it to the required, so this will get addressed to the extent. But we are more focused on the safety of the reactor and we keep on adding every now and then the safety features, which includes or increases the cost. I don't know whether any time we have discussed on the cost reduction of the reactor components or accessories or what. So this may be one thing wherein we can further venture how to bring down the capital cost of the nuclear power plants. Then gestation period, anyway, if it is rightly planned and contracts are awarded in a planned manner, win-win situation manner, So this can also get addressed. Renovation and modernization is seen as a cost-effective option for restoring full generation capacity, improving availability of the existing nuclear power plants, and better assessment due to its low cost and short gestation period. We do maybe after 20 years of reactor operation, that reactor channel life is over. So expense of roughly 300 to 330, 340 crores is there, and total reactor is rehabilitated. This includes upgradation to some extent, and it is again ready to work for next 20 years. Besides improvement in the generation availability, and other benefits achieved include life extension, improved safety, reliability, and environmental conditions. Life extension of the existing NPPs offers economical option to meet increasing power demand and reduce CO2 emission. What is the need? Renovation and modernization. Because some of the reactors are, that 20 years old, 30 years old, 40 years old, obsolete design. So at times we have to come out for the new design or new equipment or new system. Or high rate of failures is there in any equipment that we need to replace. Indigenization, indication of degradation is there in any system, we need to address to that. Efficiency improvement, or any new regulatory requirement is there. Operating experience from national or international events. Like Fukushima, after Fukushima incident, we did lot of modifications in our reactors to further strengthen the safety of the reactor. New codes and standards also require that renovation and modernization thing. Then further new experiences anywhere. Then refurbishment of the reactor. This is a major plant management life enhancement activity. Here we cut and replace the end fittings and pressure tubes. We call this en-masse coolant channel replacement. This is a highly dose intensive job because pressure tubes may be having a radiation field of 10,000 R. Then end fittings we remove, shield plug we insert into the pressure tube, and all those components are disposed of, and new pressure tubes and end fittings are installed into the reactor core. Then next is the EMFR, en-masse feeder replacement. Feeders also have some flow accelerated corrosion, and even for the ease of working on the coolant channel, it is better to replace all the feeders at the same time, and we are replacing them with a further better material. It is chrome moly used nowadays. Then for old reactors, Rajasthan 1-2 and Madras type of reactors, Rajasthan 2 is already going EMBHR, that is boiler hairpin replacement. So because of aging, there was thinning into the boiler tubes, and there were this probability of leakage, and minor leakages have happened in the past. So we have planned for en-masse boiler hairpin replacement. It is under the process. Then utilize the opportunity to upgrade or replace the obsolete systems. During this EMCCR job, we look into the other systems also and upgrade them, just like moderator system. Earlier, we were having moderator pumps with mechanical seals. Now we have replaced them with can rotor pumps, that is zero leak pumps. So further upgradation opportunity also we are not missing out during this EMCCR job. Concerns during refurbishment is the radiation dose intensive work, need excellent planning and implementation, long period of outage, maybe 1.5 years. And this is a new reactor almost. We have to do all the commissioning activities, including first approach to criticality. All spent fuel bundles are removed and new fuel bundles are loaded into the reactor core. They are removed prior to the pressure tube cutting. Then collection of pre-service inspection data. We have mastered the art of refueling, defueling, whatever is there. During the fuel crisis period in Narora 1 and 2 days, when Narora 1 was to undergo EMCCR, we were having partly utilized fuel bundle because there will be different fuel, different burn up for the bundles into the reactor channel. Some of the bundles are used up, but some are having again the reactivity content. They can be used. It was the first time we used fuel bundles, spanned fuel bundles from one reactor core to the other reactor core. And there was no degradation because it has to pass through air, then light water system, then again to heavy water. There was no IP downgrading in PHT system, and there was no fuel failure or any increase in iodine activity in the other reactor which we used with the used fuel. So that was a maybe not done anywhere else outside India. So that has saved maybe 20 crores on account of utilization of already used fuel in one reactor to other reactor. And this is again, tech spec forbids this. Technical specification says that. Technical specification says that any spent fuel bundle which has undergone dry transfer operation cannot be reloaded into the reactor. We got safety clearances from safety committee, from regulator, proved the procedures and practices for that, got permission and executed the thing. Then hairpin replacement that I already discussed out. These are some of the pictures. Boiler hairpin replacement in Rajasthan too. At the location, hairpin. Degradation we have already discussed. Material change of feeder pipes we are replacing with the chrome moly. Calendia and sheet tube. At the end, red portion is end fitting. In the center, it is pressure tube shown. This is a typical view of end fitting channel inside. You can see the face of the reactor face, channels and the feeder pipes going up, connecting to the header, reactor header. We all cut and remove this feeder pipes during EMCCR, cut and remove all end fittings and the pressure tubes. This is the working, these are panels. This is a working reactor face with a sealing plug, you see, in the end fitting, sealing high temperature and pressure D2O. D2O, 20,000 rupees a liter, you can see. Mock-up facilities, training qualification. For coolant channel replacement, we carry out preparatory phase, removal phase, inspection phase, reinstallation, then recommissioning phase. These all places we have already done the refurbishment and replacement of the reactor coolant channels. So we have got sufficient expertise with the industry available, Rajasthan to Madras. We do periodic safety reviews also and submit the report to AERB. Plant modification safety upgrades are carried out based on the operating experience sharing from the nuclear power plants and world over. We do renovation and modernization based on the root cause analysis of the event, based on the operation and maintenance experience, based on the inputs from R&D and evolving designs. Following modifications carried out at NPS and other NPP to prevent, like increase in the radius of the lancing rod. This is out of that Narora fire incident subsequent to scalping of blades. This is with respect to the turbine, chamfering of the shaft, sharp corners, introduction of the ripple springs, C&I components, whatever renovation and modernization we do during the EMCCR job. Lot of equipment system components are upgraded with the new versions. Electrical system protection relays changes from static to numeric, TG AVR replacement to DAVR. So a lot of improvements in the electrical system, mechanical equipments, other modifications to improve system availability, reliability. We have introduced further safety features, reactor trip-on based on the Fukushima event, water injection points, seismic trips, fire injection to the coolant, moderator and shield, external water injection, seismic qualified emergency underground water tank, diesel-driven pumps. This hydrogen management is also being taken care subsequent to Fukushima accident. Yeah, thank you. Thanks a lot.
Thank you very much, sir, for your very exhaustive and very informative address. It covers the entire spectrum of plant life extension, modernization and renovation of nuclear power plants. Very thankful to you. And now, moving to our second address of this session, we have with us Mr. Ravi Subramaniam, who is Director Conformity Assessment, IEEE SA. And we are thankful to his organization for being kind enough to be silver sponsor for our event. And he will share his insight on the nuclear power electrical equipment certification program. They have developed quite good expertise on it, and he's there with us to share his insight. Welcome, Mr. Ravi Subramaniam.
All right. Thank you, everyone. IEEE is very glad to be here at this event amongst many of our nuclear experts here in India. I'm here to speak a little bit about standards as well as conformity assessment for nuclear equipment qualification. So I'll try to give back some time. I'm going to try to stay on time. How many of you here are IEEE members? Can we see by a show of hands? That's okay. We have about 2 people. That's a positive sign. I think we need to do a better job. So IEEE Standards Association, whom I represent, is responsible for developing open standards. Our major goal is to advance technology for the benefit of humanity. We truly are an innovative organization. We promote innovativeness with public safety and health and well-being of people in mind, contributing to a sustainable future. So just look at some numbers. IEEE has approximately 1,500 standards under development at any given point in time. We have almost 400 corporate members worldwide. Some of the largest tech companies, including even smaller startups. We have 7,500 individual members. We have more than 40,000 global participants, and we also have agreements with a lot of government agencies, regulatory agencies globally that exceeds over 180 organizations. So IEEE has been developing nuclear standards since the 70s, in fact, maybe even in the late 60s. These standards are preeminent standards that are being used globally even as we speak. How are these standards developed? So all of these standards are developed under the auspices of the IEEE Power and Energy Society, which is overseen by the PES Technical Council. And under the Technical Council, there are many different committees, and the committee that's responsible for nuclear standards is the Nuclear Power Engineering Committee, or NPAC as we call it. And within NPAC, there's 5 subcommittees looking at various aspects of nuclear power plant development. Some of the standards I'm going to talk about today, it's kind of consolidated within SC2, which is qualifications. But we have the other subcommittees that looks at human factors, safety-related systems, and things as such. IEEE standards are being adopted and used worldwide, as I said. In fact, the first IEEE standard, the 1974 version of 323, is still under regulation under the US reg guides. However, recently we published the most recent version of the standard, the 2017 version, has already been adopted into the European norm since 2017. And we are beginning to see a large increase of participation because it's now a dual logo standard. It's an IEC as well as an IEEE standard. Within the North American region, which also includes Canada, IEEE 323, the 74 version and the 83 version is actually called out in the reg guide. Very recently, even during COVID, there was an open comment period to adopt the 2017 version into the regulatory guide. So there's now a new draft guide that endorses that. Very soon it's going to be published in the regulatory guide. In terms of Korea, Korea has been using IEEE standards as well. We do have a memorandum of understanding with COFONS, which is a Korean Foundation for Nuclear Safety, which is one of the regulatory bodies. And then I've included others here, including Slovakia, Czech Republic, Japan, Sweden, Finland, that are all utilizing IEEE standards in some form. and I'm pretty sure India is probably looking at them as well. So several years ago, I originated a committee that looked at certification of nuclear equipment for safety. We gathered a committee of experts globally that really looked at that all Class 1E devices used by nuclear power plants worldwide should be conforming to the standard 323 and other applicable IEEE standards like 344 for cables and so on. And they even took it a step further. They said it should be certified. Just a manufacturer self-declaration is not sufficient. It has to be certified. And that same committee also said that they should be utilizing standardized test plans, test specifications, and test report templates. Anyone in the nuclear industry is probably familiar with the fact that you might come across a 3,000-page test report. It is a very normal thing. And to review that and to look for anomalies and things embedded within that report could be a pretty arduous task. So really looking at standardized templates, and conformance should be conducted by third party. And assessment of test laboratories should also be conducted. And they also wanted to go a further step to say certified devices should probably contain some kind of a certification mark that attests that the products have been tested and certified by some independent organization. And the last bit is very interesting, and I'm going to talk a little bit more about that, is to really look at a software solution to help manage the entire process of equipment qualification. Most of you know, I think even my preceding speaker was talking about, the whole life cycle of equipment qualification. It is a big process, and a paper-oriented process never really is very efficient. So who are all the stakeholders in this process? I think most of you are familiar with, the systems integrators and the nuclear power plants and component vendors, equipment vendors, but regulatory agencies, plant designers and engineers, the testing facilities. Maybe India's landscape might be slightly different, but if you go to some other countries, there are actually nuclear commercial testing facilities that provide these services. So how are they being held accountable? How do we know that the quality of those lab testing results are being monitored, right? And then we also even looked at insurance agencies. So insurance agencies have a keen interest because they are underwriting the development of these types of projects. So they want to have some safety security that the products have actually been gone through some level of scrutiny, right? So we started to piece together this plan, and we wanted to come up with a certification program. So the goals of the certification program, or the benefits of the certification program, is to sort of mitigate uncertainties, really look at cost savings on verification of products, and also conducting audits. So NRC performs a lot of audits. NUPIC is another organization that performs audits. So it could become a very costly venture for someone who's involved in the nuclear business. So how can we consolidate all these things to make it a lot more efficient? Fraudulent and substandard and counterfeit products. This is a big, even in February this year, US published an article saying that they found about 100 devices that were CFSI, out of which 5 of them were actually identified as critical to safety. So these are real problems that we are encountering, and we really need to look at them very closely. And then also looking at independent assessment. So what is the value proposition here? So I'm going to put the utility hat on, right? Let's say you are an operating utility, you're looking at building additional plants. Having a common shared resource for testing and certification is automatically going to streamline and help you achieve lots of efficiencies and also reduce your costs. And there will be reduced burden if you have a software as a service program that would help you automate the EQ binder. So is everyone familiar with the term EQ binder in India? Yes, no? So an EQ binder is something that is a file that is built together or put together throughout the entire life cycle of the development of the plant and through the operation of the plant until decommissioning, right? So what equipment goes into the plant? Have they been tested? What if they go through design changes? How are they being reviewed for conformance and things like that? Product certification also includes independent technical review by IEEE before it gets certified. And having certified products ensures conformance, right? It is a legally binding contract. So if a manufacturer were to come to IEEE and say, I want this product certified, they have to go through an approved lab testing process. And then in order to bear the IEEE logo, then they can go to market saying that they actually have gone through due process to meet the requirements of the standard. So really our goal here is to minimize risk, lower the occurrence of fraudulent substandard parts, and also to manage continued conformance of the product, because products, material changes, all those things happen during the entire life cycle of operation of the plant. So from an equipment component manufacturer standpoint, the benefits are somewhat similar, but I would also look at a potential national and global market reach and expansion. And then even from a test specification standpoint, one of the chief complaints I hear from manufacturers is, we don't know what the spec is. How do I know what is the spec of this plant? I don't know how to design my product and test my product to show that it would survive in such a plant. So this is a major consideration that we took into development of the software as a service, which I'm going to show a little bit here in a few minutes. So this helps from a manufacturer standpoint, helping them to plan their resources, budgeting, and project management outlook. And then the other benefits are somewhat similar. Also from a laboratory standpoint, having recognized laboratories. Not every laboratory is the same. Speaking to some of our working group experts, they said that one of the labs attempted to conduct a 365-day test on a cable within 30 days. Okay? We laugh about it, but it's an actual occurrence. A 365-day test was crunched into a 30-day test, which the cable manufacturer was trying to sell to a nuclear power plant. And these are all critical issues that we need to address as an industry. It's not an IEEE problem, or it's not a nuclear power plant problem, or it's not a regulatory problem. I think we all need to sort of join hands. So what we have done at IEEE is we have come up with a lab recognition process, which also uses a 3-star rating system. And the auditing process that IEEE employs really has taken all of the contents of NQA1, Appendix B, and also the ISO IEC 17025 requirements to look at how the labs operate their quality assurance system, and also look at their technical competence to perform these tests, whether it's environmental testing or seismic testing or EMI, RFI testing. So a 3-star lab is a lab that has all pretty much their act together, and they can perform lab testing independently. A 2-star lab would be a lab that probably is pretty confident. However, we want to see a test plan and approve the test plan before they can conduct it. And then a 3-star, or rather a 1-star lab would be a lab that would be 100% under witness testing. We took this approach because in some countries, we saw some labs were ramping up to help with the nuclear power plant build that had the right equipment, the right people, but maybe not enough experience. So we didn't want to, push them aside. So we wanted to give them an opportunity to be part of the system and grow within that system. So we looked at a 3-year audit cycle where we would go on site and audit those labs. And every 18 months, we do a desk audit. IEEE worked with some of the most eminent labs in the world that does nuclear equipment qualification. As you can see here, we worked with NTS and Kinetrix in Canada. We completed audits of some of these facilities this year. including last year. In fact, we announced some of them earlier this summer as well. We also have an extended pipeline of other labs and manufacturers that are awaiting audits. So we will be continuing to grow this pipeline as in 2023. So the audits process would be, the lab would determine the scope. There will be a documentation audit, and then we would go and do an on-site audit with a team of QA experts and technical experts, which will be assembled by IEEE. So again, the goal is to look at their technical ability to perform the testing accurately to the standards. And then the authorized labs would also be published by IEEE. And they could be independent labs or even a manufacturer's lab. So they are permitted to perform testing as well. So we looked at what is a laboratory scope. This is an old scope that we initially utilized, right? And then eventually we said, well, we want to streamline this a little bit. So we went to this new scope where we kind of broke it up into environmental qualification, harsh inside, outside, containment, radiation only, relative humidity only, mild qualification, submergence, aging, and flame testing. And then on the other side, we have seismic, EMI, RFI, which is planned for the future at this point in time. So what is the certification process? All products should be tested at an IEEE recognized lab. All the test reports will be reviewed. Once the lab completes its testing and puts together the final report, it would be sent to IEEE, which would then review this for technical content and accuracy. And once it's done, they would then be certified. They will go through a certification process. They will have to sign a certification agreement. Why this is critical? Because when there's a legally binding agreement, the manufacturer cannot go make changes to the products without informing the certifier. Okay? Because the moment they make changes to their product literally becomes uncertified. So it is critical to have that additional layer there. And all certified products will be listed on our registry. They can utilize our logo. And all of the products will be traceable and ensure that they are continuing to be compliant to the requirements throughout its entire sales cycle. So this is just more of a graphical process, a graphical picture of how this happens. So manufacturer works through the EQ Navigator, which I'm going to talk about. They will go to the test lab to engage for lab testing. Final reports from the lab comes to the certification agency, which is IEEE, conducts the technical review. And once the technical review is complete and it's successful, the manufacturers will receive a certificate and they can market their products globally. This is our certification mark. Does anyone know how long it takes to build a EQ binder? So some very conservative projections has been 120 hours or more to build a binder for one device, right? So it's a pretty large, laborious task to actually build an EQ binder. So what are some of the risk factors? So there's a heavy reliance on accurateness of the data being provided by manufacturers and labs. So there's a lot of trust that the data you're receiving is accurate. Binders are not standardized. I talked about the 3,000-page report, and you're trying to look for a needle in a haystack, right? Identification of substandard or fraudulent parts. These are major risks if you don't have a certification process. Updating the binders could be a complex process. I had an occasion where a manufacturer had put in some design changes within that 3,000-page document, and it could take you days to find what those anomalies are. So we embarked on a software system that can help manage this process, which would literally help you save 80% of your costs and time and resource spent on formation of this EQ binder. So having an EQ binder, it's completely electronic. So there's no more reliance on paper reports. You could make the changes online. They are all time-stamped and user-stamped. It becomes a lot more easier to find out if somebody had wrongfully put in some fraudulent data or incorrect data. There's traceability based on that. Obviously, this helps you to reduce the time you spend on managing your EQ binders. And then really monetarily, efficiency is increased. Duplication of work is also prevented by utilizing this. So the EQ Navigator was purposefully built. It's an IEEE process to bring in the labs, certified products, and nuclear power plants. So really the entire ecosystem of labs, manufacturers, and plants, and utilizing all standardized specs, plans, reports, and then building your EQ binders. It's a 100% website-based tool. It's a subscription-based tool. So you can go to the website at any point in time, anywhere in the world, utilize the tools that are built in within to manage your entire product and plant systems. Here are some of our early adopters that have been utilizing this program, RSCCT connectivity or RayCam, as you might call some of their products that have been using these. So really the software as a service helps you with the management of the labs. So labs use them, manufacturers use them. It helps to manage the audit process. It also helps to manage the testing process for environmental and seismic. And then also from a utility standpoint, helps you to manage your plant packages. So that's sort of my conclusion. We have some technical contacts here who are my committee chairs, who are extremely welcoming. So you're more than welcome to email them if you have any questions, but you're welcome to reach out to me as well. With that, I don't know if you have time for questions, but thank you so much for your attention. Yeah.
Is there any question?
Yes. I think we need a mic.
Hello. So just a quick question. EQ binder, you said that it allows seamless transfer of documents. The question is on document management system. Does it, the DMS is owned by IEEE or it's the external collaboration you have?
No, the great question. So the reports are always created for the manufacturer. The system, the software as a service system will enable the manufacturer to share this with any of their buyers with the nuclear power plants. So they are not owned by IEEE. They are always owned by the person who paid for it, right? So even the labs may create the reports and they deliver it to the manufacturer, but it's up to the manufacturer to decide. Because the power plant might say, I want to receive the report directly from the lab, not from you, because you may have gone in and changed something. So the software is built to manage that whole process. Because if somebody tried to go in and change something, it's going to time mark and stamp what was changed and how, who made those changes. So it's kind of a very foolproof, very secure and cyber secure system that will help you manage that process.
Okay. For convenience was fine. My question was related to that security only. Thanks.
Correct. Thank you.
Thanks for a very interesting session. My question is simple. If a product is qualified for another standard, let's say RCCM, is there some equivalence or is there a shorter way of getting the product now qualified under the E1 category, or does one have to start from scratch?
Yeah, I would encourage asking for a demo, because the system itself is not just focused on IEEE standards. There are multiple other standards within the templates that you can pick, including even APRI standards. even some external standards. So it is a pretty robust system. We obviously want to have feedback so we can expand if there are some country-specific requirements. It's definitely malleable enough to include those types of things. But in respect to that particular standard, I'm not sure, but I can check on it and let you know. Yeah.
Thank you.
Any other question? Anybody interested to ask?
So two things I want to say, if there's no other questions. I think the nuclear industry is pretty strong. I come from the US. The recent Bipartisan Infrastructure Act has set aside $6 billion in funding to help extend the lives of some of the plants. Of course, the US is not a great example. They're really going through sort of decommissioning and things like that. But there is a concerted effort, even through the Secretary of Energy, Jennifer Granholm, in speaking or attending some of the meetings with her. They are heavily interested in expanding nuclear and hydrogen. Also, one thing I want to say about what I have presented, there is a strong need to create this new workforce, because a lot of the nuclear energy workforce, we have lost a lot of people to retirement, and that knowledge is gone, right? You can never recapture that. So having some kind of a process like this is going to help retain that knowledge, where we can now start retraining the new breed of engineers coming through. And this kind of really falls into the IEEE's goals of standards, education, training, workforce development, and ensuring safe society, right? So I want to sort of end with that. So thank you so much for your time.
Thank you, Mr. Subramaniam, for your insightful address. And now moving to our next address, I would like to request Mr. Vice Admiral NF Nadaf, Nuclear Business Advisor to Walchand Nagar Industries. He will be speaking on manufacturing infrastructure for critical equipment in India. Vice Admiral, sir, please, request you to be on the dais.
This remote works. This is forward and this is reverse. Green one.
20 minutes.
Good afternoon, everybody. Let me first thank the Indian Nuclear Business Platform for giving me an opportunity to talk on the subject of manufacturing infrastructure for the critical nuclear equipment. Necessarily, what I am going to talk is, since the major players in the nuclear industry and nuclear design engineering faculties are here, it's only a kind of a collection of our data and information for the benefit of everybody who is wanting to enter into a nuclear field. So let me start with this. So what it entails is that we need a nuclear engineering knowledge. That is the basics. If you don't have the pulse of the nuclear power or nuclear engineering, then whatever you are going to manufacture may not be meeting the technical requirement of the equipment. So therefore, the basic requirement in nuclear engineering knowledge, then the design engineering of equipment and systems for the nuclear power plants. Now, why this is required in case of a manufacturing agency? Because there is a lot of work which is kind of left over by the design engineering organization which floats the tenders, and therefore residual design engineering work is considerable, which I am going to talk subsequently. Then awareness of various codes like RCCM, Russian codes, American codes, of course, Then welding facilities, experience in the materials handled, additional qualifications. These are the topics which I will be talking. In-house quality assurance, NDT, enable accreditation of test facilities. Then space, cranage facilities, manufacturing facilities, machine tools, clean halls, etc. So let's come to the nuclear engineering knowledge and the design engineering part of it. So I mentioned about the good knowledge. Deep understanding of the codes is required. Residual engineering is required in many cases, and that the supplier has to do it. Also, there are some defects occur during while manufacturing, and these defects have to be analyzed. The in-depth analysis is required to be undertaken. The causes are to be established, and the remedial measures are to be taken up. These are to be approved by the organization who is placing the purchase order, and once they are approved, then only you can undertake the defect rectification. Then obviously modern design tools are required, software and hardware is required, and the deep knowledge about engineering. We also need to undertake many jigs and fixtures design so that we can manufacture the critical components. So that is also a part of engineering. And so therefore a strong design engineering team is required. This I have talked about the various codes, because these codes are applied in not only design but also during the quality assurance stages, and therefore knowledge of these codes is very essential. Some of the organization insist on some of the ASME stamps, etc., or nuclear standards. These are required. Now, materials are very important. Welding facilities, and related to these weldings, some additional qualifications are required. Now, some of the nuclear materials which are currently being utilized are indicated here. This is not the complete list, but I think it covers majority of the materials. So the knowledge of all, detailed knowledge, that means chemical knowledge as well as the material properties, both during fabrication as well as heat treatment, these are all in-depth knowledge is required, because that is applied in a day-to-day performance of the fabrication. Welding equipment, of course, standardized equipment are there for the various processes like TIG, MIG, etc., orbital welding, etc. So these are all standardized equipment which is required, and the size and shapes and the power requirements is different for different materials as well as this different applications. So heat input and the distortions which are occurring during the welding, and the control of the distortion, the prediction of that and control of that is very essential in order to meet the technical requirements of the component. Pre-welding, during welding temperature, post-welding and heat treatments requirements are required to be understood well, so that you can perform them as per the technical requirements. Special jigs and fixtures are required while welding thick plates. Blind ends sometimes are required to be undertaken, and so the special jigs and fixtures are required to be designed. So these are some of the features. Strip cladding machines. In-house quality assurance is very important. This will be destructive as well as non-destructive tests, and preferably you should have in-house NABL accredited lab, so that you can undertake the tests while the equipment is getting manufactured, so that you don't lose time. Of course, you can go to the outside industry and get the test done up, but there is a loss of time, and sometimes credibility of those tests also is in question. So for all these processes, UV, RT, MPT, DPT, you need equipment of varieties of types. Qualified manpower with appropriate qualifications, level 2, level 3, as per various standards, and the NDT technique knowledge experience is required. Once you undertake a test, then interpretation of those results is very important. And based on that interpretation and discussion with the quality control team from the customer, one can take a decision for further actions. In-house laboratory, NABL accredited is preferred, as I mentioned, but outside labs also can be used. Now, many times a residential inspector of the customer is available at the supplier's works, and that really helps in doing the work 24 by 7. So some of these equipment, I'm just showing you pictures. Space, material handling facilities is very important. This is the overall picture of Walchanagar Industries. Various workshops you can see. Inside the workshop, you should have necessary cranage facility. These days, requirement is to the tune of 150, sometimes 250 tons internal handling. And so the height also is important because some of the components are very big, and therefore the height below the crane hook is an important issue. So you can see that how big components are getting handled. So such kind of facilities are required. Then manufacturing facilities, machine tools, and clean halls. Now this is in general. You can see a large area which is required with various machines. Little more details I will show you picture by picture. So you can see the workshop with various machines. These are pictures of Walchanagar Industries, and the clean halls, they are very important, especially during welding and assembly stages. And furnace. Number of types of furnace are required. Some horizontal loading, some vertical loading, some small, some big. So varieties of furnaces are required for heat treatment. So what sustains such infrastructure? Because the investments are very large, both in terms of infrastructure buildup, operating them with a very highly qualified manpower, and sustaining them for a long time without jobs is very difficult. So you need a very competent manpower to operate them, and therefore continuous business to feed the created infrastructure is very essential. Good financial clauses in contracts so that cash flow issues are under control. Many times now things are changing quite a bit, and therefore this is an important point which during discussions I will bring it out. And then conducive environment for the workforce. There should be no strikes, no political interference, etc. That is very important. And good customer-supplier relation. This is also a very important thing. Earlier days, people used to talk about, especially for the new projects, that the industry is a partner. Now that word is very important for inclusiveness, to feel for the supplier, that is the industry, that he is a part and part of the owner of the new system is very important, because that gives a very good results. So with this now I'll just show you some of the important issues of how Walchanagar Industries, which is set up about 110 years back. So the history of patriotism in the air, on the land, and in the sea. These are the basic creation of Seth Walchand. And he has created Walchandnagar industry at near Baramati, near Pune. Hindustan Shipyard, which has been nationalized, which now construct the ships and repair submarines. That is a sea version. HAL, Hindustan Aeronautics Limited, which was created in 1940 to support the Second World War effort of the Britishers, which was again nationalized and currently a premium organization for the aircraft production. And premier automobile, which is the Fiat car, which has been driven by old generation people like me. And Hindustan Construction Company, one of the major company in the civil engineering, which does the major works for the nuclear, then for the bridges, dams, etc., and Scindia Steam Navigation Company. So this is a tradition of 110 years, a kind of a nation building tradition which we have. Current businesses are basically defense, aerospace, missile and nuclear. So we will focus little on the nuclear part of it. Now, what is the snapshot of what are the experience? More than 5 decades we have been working with atomic energy, starting from the research reactors. I will show you some pictures of the capabilities and what equipment we have delivered for the research reactors, followed by 220 megawatts of reactors, 500, 700 now. Also for the submarine reactor. The human skills, we have about 100 plus engineers, 500 plus skills, workmen dedicated to the nuclear work. Manufacturing facilities, I have shown you some of the pictures. And we have plenty of space available. About 3,000 acres of land is around the Walchandnagar is available for utility. Then quality assurance as per the various national, international codes and standards. 5 minutes, sir? Okay. 5 minutes. So that is there. Quality assurance, technical support. Then present focus, we all know this. So I will not spend time. Issues need to be addressed for SMR. This is again a separate topic which I will not deal with it much. So let's go through this. So this is for the research reactor. We have supplied equipment for 220 and 500 megawatts. This is equipment supplied 700 megawatts. So we recently got the orders. Some of these components you can see. Thank you. Any question?
Is there any question for Vice Admiral Nadab? Thank you very much, sir, for your address on manufacturing infrastructure for the country and having an overview of your company in this in this segment, and quite useful for our knowledge and information. Now, moving forward, we are having an interesting discussion for the day, and the discussion would be on make nuclear in India and for the world. This is basically post COVID-19 and the evolving geopolitical scenario. India has an opportunity to play a significant role in strengthening international nuclear supply chain to support the domestic as well as nuclear program undertaken by different world countries. Because many of the Western countries are such, they have technology, but they don't have the kind of project management expertise which is required. Fortunately, India has been it has been the slow progress, but it has been a consistent, efforts to develop nuclear power plants, and now our construction has never stopped. So that's why we have a competitive advantage on that. So India has the potential to emerge as a destination for all global nuclear companies which are looking at India not just as a market, but as a pivot for their cost reduction strategies to support their growth aspirations world over. Whereas Make in India program is being well received across different sectors. In the nuclear side, not much attrition has happened so far. And India currently has, and in the morning session, particularly in the keynote session, Dr. Kakodkar was also referring to the PSWR technology, and Mr. Sunil Kumar was also, in his address, he explicitly mentioned about how PSWR technology is going, how good we are performing in that technological field, and currently this is one of the cheapest technology that India has. And it is, and this is the cheapest in the world. And perhaps not as a technology, but it could be a reference for world to follow and to understand how costs can be brought down. Of course, we want to bring down the cost of PSWR also, but then it has set a reference for the world how costs can be brought down. Perhaps if not the technology, the learning, the methodologies and processes give a lot of idea to basically bring down the costs. Being a centralized hub for global nuclear supply chain, if India go for it, costs can further go down as a result of economy of scale, large supply base, and resulting synergies. So we have a very eloquent speakers for this panel, and we will be discussing on all such opportunities and challenges as how to make nuclear in India and for the world, and how it can be made possible. So with this, I would like to invite Dr. A.K. Nayak, Head NCPW, Department of Atomic Energy. Please, sir, have your seat on the dais. We have with us Shri N. Ram Babu, Executive Director, Nuclear Business Electronic Corporation of India Limited. We have with us Vice Admiral Nadaf, Advisor, Nuclear Business in Walchandnagar Industries. And we have also with us Mr. Shahnawaz Ahmed, Senior Advisor to World Nuclear Association. Mr. Ahmed. Oh, he's from there. So I welcome all the distinguished panelists on the stage. So just as a brief, the format would be like we would be starting with the opening remarks, and then we will delve deeper into the deeper aspect of it, and then it will be followed by the question answer session, and finally some concluding remark. So starting with Dr. Nayak, so what are your thoughts on make nuclear in India and for the world? Your opening remarks, sir.
Hello, very good afternoon, or we are at 4 p.m., almost 30 minutes late, so coffees you must be also looking. But what I'm going to sensitize you, two aspects. Time is short. No, time is not short for coffee. Time is short for all of us for different aspects. Look, one aspect since morning I was hearing, but probably little spoken. that what time frame do we have and the world is having. Let me tell you, this, if we believe the IPCC analysis, that is International Panel for Climate Change, their projections, today we emit something like 60 gigaton of CO2 per year. And the IPCC projection says that if we want to limit 2 degrees Celsius, the world can bear something like 1200 gigatons of CO2. So if I divide by 60, it's just 20 years left. With the current projections, what we are, current rate of CO2 emissions. So today, 2022, if I had 20 years, it is not 2050. Forget about 2060, 2070 and all. So 2050, I believe, is still a bad projections. That is one point. Second point is, if we have to really achieve net zero, as Dr. Kakodkar Sahab also spoke in the morning, nuclear, apart from renewables, has to play a major role. How much nuclear? He spoke 2,500 gigawatt. And today, how much we produce? 7 gigawatt. For India, I'm not talking about the globe. So 7 gigawatt to 2,500 gigawatt is unimaginable. That is one point. In fact, forget about 2,500 gigawatt. I myself had done some calculations, especially for India. Today, we produce close to 9,000 terawatt hour per year, total energy, which includes electricity also. And the renewables that we have, something I defer what Dr. Kakodkar Sahab said in the morning. Today, our total potential of renewable is of the order of 4 to 5,000 terawatt hour. But MNRE projects and other projections also, including Niti Aayog. The remaining is, as on today, is roughly 5,000 terawatt hour per year, which has to come from nuclear. And if I divide that with an energy system having very high capacity factor like nuclear, it's something like 7 to 800 gigawatt electric. So 7 to 700 means 100 times we have to jump. In what period? Less than 30 years. At morning till now, what I am hearing, we're all talking about micro things. This micromanagement, this, that. I don't want to speak out. So 7 to 700 gigawatt, are we all ready? How many industries are ready in India? This is a really difficult question for us to be answered. But let me tell you what business potential we are having. This is I will read out because I prepared it for this talk. What International Energy Agency has projected for India at net zero. We need to have something like 520 million tons of hydrogen per year. How much? Please remember these numbers. 520 million tons of hydrogen. And ambition today is $1 1 kg of hydrogen, which is not possible. Maybe it is $2 to $3, but I take the cheapest. $1 1 kg, it itself is $520 billion. How much is the hydrogen business for India? $520 billion. Similarly, approximate transport energy is something like 3,750 terawatt hour. That comes to something like $235 billion. Similarly, 90% of electricity has to be produced from renewables. Like morning, I just tired of, along with renewables, the nuclear together is something like $1,200 billion. Similarly, 85% buildings has to be from clean energy. That itself is $91 billion. Most important, 7.6 gigatons of CO2 have to be captured. That itself is $600 billion. If I add up everything, together it is $2.6 trillion business. When? In net zero. For whom? For India alone. Ready here. All industries are sitting here. It's a big opportunity for all of you. But I don't want to hear the projections. I have manufactured 10 end seals in 20 years or 20 steam generations in 50 years. That is not the industry we are looking for. Our DAE, I will expect, can we increase 100 times, 1,000 times of that production capacity? Thank you.
Thank you, sir. Thank you for your opening remark. And now I would be moving to N. Rambabu sir for your opening remark on make nuclear in India and for the world, how it can be made possible.
Good afternoon to all. I am Rambabu from ECL Hyderabad. I will talk about the contribution of ECL towards the nuclear. Basically, the last 5.5 decades, we are in this service of the atom. We are not only supplying equipments and control and instrumentation system to all the nuclear power plants, to all other test reactors and PFBR. These reactors also we are regularly supplying the equipments. In addition to that, in this process, we have also developed the certain equipments which contribute to the nation through defense, space, then security, homeland security, IT and e-governance. All the areas we are having 5 verticals, and all the 5 verticals are in the supplying the equipments and systems to the nation through various agencies. Yes, as far as the self-reliance or Atmanirbharta is considered, yes, we can say proudly now today ECIL is capable of making what is required for the PHWR. 100% radiation monitoring or control and instrumentation, whatever may be the requirement of PHWR reactors, I can say proudly that ECIL is manufacturing at Hyderabad. Except only the shortfall, what we are having is the components. And not only that, India, everybody is facing that problem that only semiconductors we are lagging. Other than semiconductors, we have got everything, and we have got the state-of-the-art test and measuring equipments, manufacturing equipments, and commissioning equipments. Everything we are having, I can say that we can contribute for upcoming fleet reactors without anybody's support.
Thank you, sir. Thank you for your remarks. And now I would be moving to Vice Admiral Nadaf for your remark on make nuclear in India for the world.
I was the program director for the India's first nuclear submarine, INS Arihant. And so some of the lessons which we have learned while executing that particular program, I would like to apply them, consider for application to this civilian nuclear program, especially for the new program which we are talking about, SMR, which is very close to the nuclear submarine reactor. So the first important lesson is that since we are entering into a new domain of SMR, the flexibility, some of the earlier panel members have talked about, the flexibility of contracting is an essential part of it, because there are many uncertain areas in which hard and fast rules may not be useful. It will hamper the progress. And therefore, the project management team should have a necessary ability and the wherewithal to tune and modify at certain junctures to help the supplier to fulfill the conditions of the supply. So this is one point. So flexibility in the contracting is an essential. Second part is that we have learned to make all the suppliers as a partners to the program. Whether it is a public sector undertaking like BHL or a private sector undertakings like L&T, WIL, and also the government agencies like DRDO, wherever we have worked, we have made sure that they feel that this is my program. Once you feel that this is my program, obviously the intensity and the depth with which the people work towards this particular program is enormous. There are no limits. There are no time limits, there are no financial limits, nothing. Everybody feels that I am working for my country. And if that spirit comes into this particular thing, then this program will be faster, more successful, more useful to it. So this is second observation. Third is that the financial management has to be good. You see, you can complete the project provided it's a win-win situation both for the customer as well as for the supplier. If the supplier is losing money, obviously he will try to find excuses not to complete the work. So at these particular junctures, it is necessary for the management of the programs, new programs like this, to visualize and see what kind of difficulty he is facing, whether it is a technical difficulty, whether it is a financial difficulty. You must extend a hand to enable him to complete his job. Because any loss of time on his account, the whole program gets lost. And if the whole program gets lost, the loss is much more than by contributing little bit, going out of way to support that particular industry and get it through. Now, the new trends which are coming in the NPCIL is that, even the cash flow requirements are not getting fulfilled. Some of the small industries, etc., they have this particular cash flow. And now the new trends is that 90% payment will be done only when you supply the equipment. That means all money has to be put in by the company. And these are borrowed money. And the banks are charging very heavily. Ultimately, these are costs add to the government and to the people. But the agony through which the suppliers go through, going to approaching to the bankers, etc., is enormous. And therefore, the financial management has to be looked into not only from the government point of view, but also from the supplier's point of view, and make his life little easier so that he can deliver better and better in time. Okay, so this is the another lesson. And the most important, another important lesson which we have learnt is that in the nuclear industry, there are certain critical materials, whether they are forgings, plates, some material. They are very, very special materials. And therefore, when we talk about a large program, these critical materials, it is better for the centralized organization to procure and then supply them as a free issue material to the supplier. Now, this will help in two ways. One is that once it is a large scale order to a supplier, then you get a cash discounts, number one. Number two, the control on the quality is uniform and correct by the customer himself. And therefore, whatever the raw material is received at the end by the supplier is in a good quality material, assured quality material. And third thing is that the money does not go from the supplier, it is going from the centralized fund and it is much cheaper. And therefore, such practices are used not only in ATV headquarters, that is submarine program, but also earlier in DAE. DAE used to procure centrally some of the critical material and used to supply. And that helps a lot in assuring the quality of the product and also, easing the financial burden onto the supplier. So some of these observations.
Thank you, sir. Now I would be moving to Mr. Ahmed to speak on make nuclear in India and for the world. How it can be, basically, question is how it can be made possible. And so...
I work for the World Nuclear Association, which is an industry organization across 35 countries. And I would like to take off from what Dr. Nayak said, that from Vietnam to Morocco, from Cairo to Cape Town, I don't find India anywhere in nuclear. So why are you not standing up and telling what you are able to tell the Indian audience here, that I can do that? I think from whatever I have seen of the world, there is a lot of soft power that our country has that we could, I know that other countries have asked for consultation from India. India has provided at the very highest level of inputs. But why is this not translating into business is something that the industry as a whole and DA in particular would need to encourage. I'll give you just two examples. Tarapur 1 attained 50 years of operation and is the oldest working reactor in the world. When we tried to get inputs for a statement saying that Tarapur, and we needed some photographs, that did not come to the organization. So I think something has to change in the mindset. I don't want to be too blunt, but I think what we need to is to own up to our strengths. We need to own up what we have done. And I just met somebody whom I had taught at the World Nuclear University, and he has come down all the way from Kazakhstan to be in India to do business. But from India, we think we can only buy uranium from them. So that is the first thing that I would like to say. The second thing I would like to say is that it's not only equipment. It is, the world has a very good understanding of our capabilities over the entire nuclear fuel cycle. It also has a very good understanding of the performance of our plants. We may not be in the SMR business right away, but I think we can do a lot for evaluation of SMRs and things like that. And I would like to encourage Dr. Nayak to sort of put this on the table in DAE or other fora, because I think it is something that I, as an Indian, would be very happy to see. But I think India deserves it.
Thank you very much, sir. Thank you for, really, it's a wonderful remark coming from you. And now moving to the second round of our discussion, as Dr. Nayak mentioned, the volume of, the kind of thing that we are basically projecting. This was actually my second question, but then Dr. Nayak has already touched upon that. So basically, so what kind of a scale up we are looking up? You have already mentioned that. And then sort of, the things that follows are the investment opportunities for foreign companies which are interested to have to get into India. So if you can throw some some light, some more, if you can more specific about that, sir, please.
Actually, this question is very simple, but answers are quite difficult. Let me tell you. Nuclear, definitely, we all agree, because we are all from the same community, that it will play a primary role. That is one part. But nuclear also has, I would say, bad word, even though they never say we are complementing nuclear. There are also other energy sectors who feel nuclear should not compete with them. This is one problem. And it is not a problem with India, it's a global problem. That is one part. And why it has happened? Because of the history. I'll tell you two things from the history. If I take before TMI, today also I was mentioning it during the lunch hour, almost 400 nuclear reactors were built in a span of 20 years globally. So 20 reactors per year, not that every country had, but 4 or 5 countries who were owning, almost 20 reactors were built per year. And 400 gigawatt, roughly that much electricity was made. And that time the technology was not so good or sophisticated as it is today. But there is a big question. Why do it take 10 years to build a reactor? It's something we ourselves have to discover. It's not only for India, it's globally. Probably is the technology is a hurdle? No, similar technology in the past people are using and building. If the regulator is creating problem, it's also I'm still wondering that there is no new discovery in the regulatory criteria. It's the same old criteria they are following.
At least not in India.
So the question is that what is the bottleneck? Is the industry not able to deliver? The industries themselves have to question. Is the suppliers, or there is an issue with the supply chain itself, or is the issue the procurement itself? Forget about the import-export, I'm not talking about. So today, sitting at this chair, looking at the business opportunities I said $1 trillion business opportunities only from the energy sector, forget about other sectors, only for a country like India. And if you talk about export, I cannot calculate, really speaking, because I can believe the full Africa is waiting, or if not full, large number of African nations today are waiting to enter into nuclear. Many Asian countries also are waiting to enter into nuclear, because everybody has realized that nuclear will play some role, or at least some significant role, when we enter into net zero. Net zero is not for India, it is a global net zero. In that perspective, I will say that the drive has to be different. I put a very bad word, that nuclear industry was today riding on bicycle. And all that projections I see from morning till now is also riding on the same bicycle. There is nobody who has come out either from industry or even from other places, I don't want to name them, how to move with this sonic speed or supersonic speed if 2,500 gigawatt have to be accomplished and how. This is something we all have to discover. Or I said, the organizer, this should be basically the topic for the next, I will say that this business platform. This should be the topic. Next, now coming to back to Indian industry. Yes, today Indian industry is totally, I will say that especially for PSW technologies, right from the front end till closing the cycle, including all aspects of heavy water reactor technology, we know. And it is proven technology. It can be exported, not only also can accelerate here. But it is not a business model. Still, I speak to our nuclear NPCIL people or the industries who are supporting also NPCIL. They are not riding on a car. They are still riding on a bicycle. That's what all that I'm saying, that contractual issues, this issue, that issue, financial issue, these issues were there in 70s also. Not that 2020, these were the new issues we were discovering. Question is that, think, I have to do business. I said, suppose today you have a small plate, tomorrow you have much bigger plate coming. Think how you have to change. And change is required and you have to drive it differently. This can be accomplished by one word, public-private partnership. Private has a lot of money, public has the technology. They have to join together and think a different mode how to accomplish this. This is one target. SMR was one of our drive few years back because for India itself, let me tell you to this audience, today in India, the coal-fired plants produce roughly 220 gigawatt electric. And this will be off the grid in next 30 years. Already some 20 gigawatt is already off the grid. And it's going to be off the grid gradually. So 220 gigawatt, I myself also had done calculation, much more than can be produced through SMRs. So there is a big opportunity for SMRs in a span of 2 to 3 decades. 30 years from now, if I say, whether it's NTPC or XYZ PSUs who want to enter, for them it is a business opportunity of 220 gigawatt from SMR. Can they accomplish it? They should come out with the plan. They can join hand with the private companies, even with the imported technologies, how to localize it in India, invest it. And I'll say 220 gigawatt is 220,000 megawatt. If I say 20 crore per megawatt, 4 lakh crore business is here in next 20 years, only from SMR. Okay, thank you. I don't want to take more time.
Thank you, sir, for your mind-blowing remarks. Thank you so much. Now I would be moving to Ram Babu, sir.
Yes, sir. As sir told that it is moving on bicycle, I will not agree fully with that. Okay, no doubt. The same thing morning we have seen the presentation of Mr. Saran, and within 5 years, less than 5 years, we could conclude Tarapur 3 and 4. And in fact, I am also a part of that. At the time, I was in NPCIL. And now why we could not achieve same thing in Kakrapara, Rajasthan? That is a major question. That one thing that really the Indian market is really capable of delivering the big equipments, because Tarapur 3 and 4, I know that all the major equipments are available at site. Other small things have come from outside, but major equipments like piece of pumps, motors, then end shield, calendar, everything was available. Then the execution was done excellently in a marvelous planning. It was done and it was executed nicely. So that is the reason we could complete in 5 years. But another factor why we could not complete the 700 megawatt in time is the change in design. Unless you standardize the design and make now we are coming out of that, they're making 10 fleet mode reactors. Probably if you give the same single order attesters to for all the reactors, probably we can reduce the span reactors gestation periods. This is one thing. And second thing, you have asked how we can support the external companies. Yes, I am ready to welcome that. I can say that we are having all the state-of-the-art fabrication facilities, because I can say that proudly today I am manufacturing 10,000 voting machines per day. I have to manufacture 20 lakhs machines before the election. So that much capacity we have built up at ECIL. If anybody, any company is willing to join hands with us, we can fabricate there all the equipments, any kind of electronic equipments we can fabricate at ECIL at much, much cheaper rates compared to the world. And all the test facilities required for the electronic industry is available. We have spent enormous around 250 crores infrastructure for upgradation of ECIL to meet the new challenges coming up on the nuclear sector, which is supported by our DAE also. With that, I would like to invite whoever is interested, the multinationals, they can come and visit, see the facility. If you are willing, we can have a MOU and we can fabricate for you. We can manufacture all your equipments at ECIL land. This way I will conclude.
Thank you. Thank you.
Just talking about the SMRs, I think the time is at essence because in 30 years, if we have to produce a large number of plants, the basic key to this is the decision on the design of this particular reactor. And we have only 1 or 2 years to take that particular decision. Now, my experience with the submarine design is that, the naval headquarters used to, read various glossy looking magazines and they used to take out the best features of all varieties of submarines and then they used to give us a technical specification which was impossible to execute. And if that is the case with the SMRs, that we read that passive cooling system and no pumps and this thing and that thing, if we all try to get the best of the all lot and we do not have design, and if we want to start a design, a fresh design, it will take years, 10 years, 15 years to undertake the design and then it becomes a non-starter. So if we have to be really practical, we have to start with the proven reactor system which will operate on the ground in coming, or groundbreaking should be within 2 years' time. If that is the target, if we are going to make it, then this 30 years and producing 100 plants, etc. is viable. Otherwise, if we are going by a very fancy design and starting design from the ab initio, etc., is not going to produce any results. So look for a design freezing. Whatever best you can do, get it. You can keep on improving upon it later on as we progress and as we gain the knowledge, etc. But today, within 2 years, the design must be frozen. That is what, if you can make that first target, then you are in the business.
Thank you, sir. Yeah, please, Mr. Ahmed.
Yes, I think it's very relevant, but I will like to state something that should be very close to ECIL's heart. Just to give you an example, the induction of new technology in any other country has been a challenge. How many technologies are there for large reactors just now? Maybe 6, 7 at the upper limit? Mr. Srinivasan? I don't think it's more than that. And we have had terrible difficulty. Today, at the World Nuclear Association, we recognize that there are 17 reactor SMR types that are expected to be operational, not operational, but on the market in the next 3 to 5 years. Okay, forget the design. The most changeable part of a reactor system are the control systems. And we are working very closely in the World Nuclear Association. We have a working group known as SCODEL, which is working with NBP, which is the regulators group, to see that the regulator understands what the industry is doing. And believe me, we are not able to convince a single regulator that this can be regulated at that level. So unless we are able to convince the decision makers, both from the technology point of view, both from the regulator point of view, we are in deep, deep trouble. So how do we do that? And I think the best thing is to start from some level of harmonization, some level of common understanding, and some level of definitions. Like, for instance, if you were to build an SMR in a far corner of a country like Canada, you would need for it to be buried and left, because you will never be able to transfer spent fuel from there across the forests, some 3,000 kilometers. So these are many issues. Will the regulator be, the fuels will be very different, for instance. Half of them, which I see, are talking reprocessed fuel. So I think these are opportunities also for countries that know how to do reprocessing, that could be on the international scale. So I think at the end of the day, for India, I would say, if CIL stands up and says, I have done this, then the world will come to you to do this further. But if you don't stand up, the question I am generally asked is, why do you want to go out of India when you are doing 98% yourself? So your strength can become your weakness. People think that particularly you have enough business at your end and you're not looking forward to it. So I think that statement needs to come. It needs to come emphatically. It will not come through governments, I'm sure. It has to come through industry.
Thank you. Thank you very much.
Just to answer this, as sir told that it is almost SMR similar to nuclear submarine reactors. In fact, ECL is mastered in that, and after the Aryanth, all the nuclear submarines are controlled by ECL supplied control C&I equipments. This is the fact, and we are doing continuously business with the Indian Navy. So we can very easily penetrate into the SMR reactors with the know-how what we are having as on today.
I have a confidence in that.
Okay. Thank you very much.
In fact, if you are talking of a country like Indonesia, for instance, which has been afraid of sitting on the ring of fire all through, but they are developing with Thorcon molten salt reactors. So people are thinking in very wide terms, as you said.
Just to continue this discussion here, very recently the US DOE has assessed 450 coal sites of America with so many laboratories involved. And they have projected roughly 250 gigawatt electric from different technologies of SMR can be put as a replacement to retiring coal plants. And believe it or not, similar projections can be done because today electricity worldwide more than 70% comes from coal, by burning coal. So this is the opportunity everywhere in the world. So to me, if you ask, apart from the large reactors, SMRs will be definitely a driver, especially to those retiring coal plants. And what is required, I also support here, the technology should be proven. If we start today, definitely it will take time. But today is a different world. There are multiple technologies available across the border, definitely. We have to join through government-to-government agreement. And most important is localization. Most important. Can we do that? And I was talking to L&T maybe 6-7 months back. How many SMRs you can make per year? I think the people might have left from here. Praveen Bhatt Saab hai. So he told me, Mr. Praveen, I can make for you 10 reactors per year within the existing infrastructure. So that time I said, within existing infrastructure, if he can make 10, probably if we expand, then he can supply for me 100. Then I asked the same question to Godrej. How many SMRs you can make for me? He said 20 per year I can give you. So like that, I don't want to speak out because I just gave 2 examples. The industry has the capability, let me tell you. They have to sing in proper tones. And the tone they have to discover. I don't want to say here how they have to discover. There is very big opportunity for them. And the SMR, apart from large reactors, as I said, in the next 3 to 4 decades, if India wants, it will be not only supplier for this nuclear technology for India, but also in the global context. Even developed countries will come and localize their components here. It's the time to join hands through proper agreement and start without wasting time. This is my what I say the advice.
Thank you very much. Yeah, so definitely this is going to be my question. So what sort of opportunities you are seeing for industry, and because this is basically about global thing also, make nuclear in India and for the world. So what sort of opportunities are there? Immediate opportunity and then medium and long term for the industry and global companies, who wants to come into India and invest here and localize the things and everything. So, what are the immediate opportunities, and if you can
see what I say that one is definitely our own technology, which is well matured. The industry is also well matured. Both are there. That is okay. The other part is this large reactor technology like PWRs, for example, which we are importing also. Most of them, they also, with some negotiations, definitely would like to come for localization. And what only today I see is a small numbers. For example, AP1006, CPR6 and all. But probably as the numbers being projected by Dr. Kakodkar in the morning, so probably the numbers have to increase with time. I don't know how many, but this can be discussed definitely. But most important is localization. The moment we go for localization, I was discussing with, for example, Rosatom a couple of months back, the price can come down by 2/3. And that will give definitely electricity market to India. It will not be difficult. That is one part. Second part is, these foreign companies should not think of only supply to India. They should think that it's my manufacturing industries. Here also there is a lot of consultancy companies today are available in terms of their safety analysis, documentation preparation, even the drawings, construction drawings, everything. Today Indian industry is different. So they have large opportunities apart from just manufacturing here. So India, I believe, can be a global hub, not only for conventional reactors, but also these SMRs. And one more technology, which I will speak probably if we have another round. If not today, now itself I want to complete. Look, India is a small country, which I have been speaking in many forums. We have small land. Today our population is 1.42 billion. And believe it or not, another 30 crore people are just waiting to join us. We will be 1.7 billion people in a very less period. And getting land to build conventional reactors itself is a big question. The type of zones we are looking, one zone, another zone, third zone. So many zones are required. Where will get land to build so many fleets of reactors? Itself is a question. And we have first stage, second stage, third stage, everything we want to complete before 2100. Assuming next century will not be there, probably fusion will be the driver of energy in India or globally. Looking at that aspect, since sites are not available, definitely as we are talking about SMR for retiring coal plants, probably and mostly micro reactors should play the major role for the energy driver, not only for electricity, but most important for hydrogen, as well as desalination, clean drinking water, and many other aspects, which I don't want to name. Today, a lot of energy is consumed with electricity is only 15 to 20%. The rest 80% is for other energy sectors. So micro reactors would play a major role because they don't need any siting criteria. They can be put anywhere, but technologies will be different than these light water technologies. I will say that it is an opportunity also for the R&D labs as well as the regulator to join hands and how to think of these technologies which should be running basically from 2050 onwards. Thank you.
So, sir, to you, I would like to ask, how is ECIL basically preparing, for nuclear scale up in the country? And So, and what sort of opportunity you are looking for collaboration on? Because, of course, if you want to go higher, if you want to scale up, investment and then collaboration, all these things matters.
As far as ECL is concerned, we are ready to take up the existing all the fleet mode reactors. We are capable of handling ourselves with little bit collaboration. We have already started negotiating with Rosatom for developing various equipments. In the Rosatom has got various units in their country, and with almost 2-3 agencies are with us for supporting them. That already we are in the pipeline, and Mr. Joshi is with us, and we are collaborating with them for developing simulators, control equipments. All those areas we have already started working. And as a spin-off technology, we have developed along in cooperation with BRC, in collaboration with BRC, we have developed the state-of-the-art safe and secure PLC. This is now the product we have launched, and we are ready to export also. So far, only PLCs are supplied by the Schneider, Siemens, Rockwell, like MNCs, only they are supplying. But today, I have got plenty of orders now I am getting from steel, oil industry, and space, especially space. They are fed up with the MNCs, and they are coming in a large way to replace all the PLCs of ISRO and other areas. So another, I think, 5-6 years, I am having a continuous supply of PLCs to the nation in India itself. Similarly, we are going ahead with, if any other companies are interested, we have got the capability to manufacture the facility. So I'm welcoming all other like EDF and all.
Sir, your thoughts on how is your organization, preparing for a scale up?
Well, the previous experience of nuclear energy last 15-20 years has not been very encouraging. The industry has invested a large amount of money into creation of the facilities, but however, the orders have not come in the way it should have come. Some of the industries, for example, even the L&T possibly have diverted their resources to some other chemical industry and other things. This is our experience. We are today talking very big things, etc. But what really counts for the industry is that if you want us to produce, then we need to invest, both in terms of manpower, infrastructure, etc. But what is the assurance that we will get the orders? Because in the last forum, 27, one of the very prominent suppliers said that you are chasing a mirage in SMRs. Why did he make that particular statement? Either he is convinced that it is a mirage, or he thinks that India is chasing a mirage. I don't know what is the truth. But if we are talking and not putting into a practice, then the industry will lose money, manpower, and kind of an incentive for doing this thing. So I think we should put it into practice more than talking about the opportunities.
Thank you, sir. Ms. Ahmed, sir, your thoughts on what kind of things international, because you come from an international background, so what kind of things internationally people talk about India, and then what kind of opportunity they are looking at India?
See, if you want me to be honest, I'll give you an example. Egypt poured the first concrete on their first reactor this year, but they already have at least 4, if not 5, and qualified major suppliers. So how many do we have in India? We have a much longer history. So we have not looked outwards, first thing. Second thing, if you really want me to be blunt, you have to keep your promises. The promises, people do understand that things change over time. Some of the people who are expecting you to keep your promises have not kept their promises. So it is mutual. It is not that something, it is one-sided. But at the end of the day, when you say it, it needs to happen. So I think that credibility only the industry or the Department of Atomic Energy can establish by I would use the same phrase, by standing up and saying it. Saying it to people who can ask you questions. Not just saying it within the country, but committing it to outside the country also. I'll give you one specific example. Again, it's Indonesia, because their mentality is also very close to ours. That the minister made a statement that they will not have a nuclear power plant before 2032. That was a statement. It was the government policy, but the minister made the statement. They have a contract with Thorcon, which is a private company. They said they'll walk out. Immediately, the president made a clarification that 2032 does not mean that it is only after that. That is when we expect it to happen. And remember, they are in the development stage. That molten salt reactor is still not operational. But what I'm trying to say is they were sensitive enough to what the outside world thought and replied to it, because it was a private sector, someone who had put his money into it, and obviously he could not afford it. So I think what Admiral Nadaf is saying is very, very valid, though it be within the country, yes. I mean, I'm sure we don't have to sort of talk of dirty linen. We don't have to talk in terms of, I'm not saying it from that point of view. I'm just saying that we should be what we want to be.
Just to continue this discussion, हम लोग कोई बोलते जो डर गया वो मर गया, ये सच है. Those who are scared, they are gone. It is an opportunity, and opportunity only those people avail who are daring. And if you look at how the business is moving, then only I will join the business. Probably you will lose the trend, like what has happened before independence for India. We didn't have the technology. We didn't have the scientific people, nor we had the skilled people. So we were dependent on the outer world. Today, after 70 years, India is different. And we know this is a global demand for clean energy. Think about there will be global demand for nuclear energy. We have to change ourselves from the strategy of that business opportunity to looking for investment. I want to be investor. I want, this is another opportunity. Let me invest so much money. Let's look at how much I get the return. Rather than looking for an order, NPCIL would give me an order, 10 orders in 10 years. I will supply to them. This is a job of a small businessman. So I'll say that if we can change our thinking process, probably we'll be the world leader. On the other hand, if we still say, I will get a order and then I will start working, probably you will have a small return. This is just a comment. Thank you.
Absolutely, absolutely.
Just to supplement that, if there is no assurance of order, like we have established everything, if I don't get an order, I don't know what to do with that. Not only that, it is very difficult to retain the talented manpower. If any talented manpower is there now, especially in Hyderabad, the day one he started wearing the born, immediately he will start how to fly to US. That is the kind of thinking in Hyderabad. Everybody wants to go there. So there to retain the person, any talented person, it is very tough job for us. And at the same time, with keeping all these, if I don't get order, then nobody is showing interest. Now we are diversifying to other areas like all other sectors we are going. So we request NPCIL in a big way to start. Let everybody to get an opportunity. If there should be a continuous flow of orders, then only the industry can survive.
Thank you very much. I have a long list of questions, but in the interest of time, now we will be quickly moving to question answer session. So, audience, if you have any question, please.
Yeah, first is the comment. It has been mentioned that SMRs are important, and definitely nuclear energy has to grow. And the players are the researchers, designers, the utility and the regulators. So the regulatory approach has been such that utility makes a design, it submits, that design gets approved. Maybe had one or two additions, comments here and there are there. This has been the practice, and the regulatory approach has been quite flexible. It has never hindered any genuine technology, which is very safe. It has a very smooth run with the regulators. So regulators are always there to help. They are not there for hindrance. The other thing is when it is coming to SMR, the ball game is little different. It is not very different. The approach is quite flexible. Good designs are awaited. Even the regulators like those designs. But here the process can be more iterative. Like you make a single submission and get it approved in one stroke may not be always possible. So maybe regulators are to be involved in the design process right from the beginning or at a quite early stage. And then there has to be a few iterations to ensure the safety. And the iterative process, stepwise, it is possible. And SMRs or any other nuclear technology, new which is coming, it can go this way. Because those days were different, and nowadays the India is different, and the technology is also different. So that was the comment, and regulators are always there to support. Now I am coming with two questions very shortly. The first one is, as it has been pointed out, it's a billion-dollar business. Yes, we do agree. But what is the motivation? When we can see some movement on the ground? So what is stopping us? So what kind of resources, what kind of money, what kind of encouragement from the government or from the private participant? What is required to see the initial inertia, which seems to be too big? We want to push it now. Let it make moving. So panel can just comment on that. The second thing is very specific question to Admiral sir. This is about the submarine reactor. So SMRs may be motivated from the submarine kind of small reactors, but the kind of safety, the kind of money, the kind of time, kind of efforts which are inbuilt into the fuel and the submarine reactor is quite high. And that kind of safety definitely is expected in civilian reactors also. But do we see economy in that kind of design if it is coming to the civilian applications? So fuel burnup, fuel utilization, and the cost point of view. So we never, definitely we can't say we never bother about the cost when it is submarine. But it is strategically important, and a lot of resources and money goes into it, and that is important. But when it comes to SMR, can the SMR, commercial SMRs afford that kind of technology, where the fuel utilization is a little on the lower side? Thank you.
The Russians are leading in this particular domain of work. And they have derived the designs from the submarine reactors to the icebreakers. So if you see KLT 40 or RITM 200, these designs are derivatives of the submarine reactors. And they are operating currently onto the ship-based systems. And they are quite successful. Obviously, the cost is, they are not disclosing at the moment, but in the last presentation of Rosatom, they have indicated a figure of 9 cents per kilowatt hour is the energy kind of a cost. If 9 cents means about 7 rupees per kilowatt hour, I think that could be considerable for Indian industry if we go by that. That is number one. Number two, they have also planned to set up land-based stations based on this size of reactors, RITM 200 or slightly bigger. Also, they are talking about 300 megawatts of electrical power reactors. So they are in the process of doing this. Now, they are working on this. America Canada, South Korea, China, of course, and these people are working. So there is a trend to go in for about 100 megawatts of electrical power in general, and then jump over to 300. And this was what is our discussion last time. So these systems, if we go by this 9 cent per kilowatt hour, I think it will be okay. Number one. Number two, these are all enriched fuels. They're from about 5% to they go up to about 18%. And therefore, the life cycle of this particular fuel change, they indicate, depending on the power consumption, etc., could be about 2 years, 3 years to 5 years. And depending on how you are utilizing these reactors, what kind of enrichment in this particular fuel, etc. So therefore, if we go by this experience, they could be attractive. Obviously, now nobody has done this on a large scale. So you have to learn from your own experience. So you have to take a chance, get into a system, a proven system, start making that particular reactor. If you have some other design, which is much better than this, but it will take time. Because any design to get maturity, it will take time. And therefore, if we have to meet the deadline of, say, 30 years time, we have to produce so much of energy, etc., you have to start today. That is what is the general approach I would like to say.
Okay. Thank you, sir. And any further question?
This session has been sort of overtaken by SMRs, and SMR being a kind of, what should I say, lollipop for nuclear industry right now. But my concerns are on the ground level that NPCIL has to put many stations of ours under international safety safeguards to account for every microgram of the fuel which we are receiving. So if we are going from 5% to 18% of enriched uranium, and we are talking not 2, 4, 5,000 SMRs during the next 30 years, how will this be tackled? I think we have a paradox here. So I'm talking like a devil's advocate, but I think this has to be also taken care of.
This I'll try to answer. Definitely concern what you spoke out. I think if you look at globally, the SMR for land or commercial deployment, the enrichment level is close to slightly higher than the commercial PWRs. It's between 4 to 5%. Except those which are for submarine applications, I think that was what they mentioned, that it's going up to 18-19%. So it is ruled out that for commercial deployment, anything above 5% today, no country is going for that. That is one. Second part, even look at that burn-up level, is also closer to that of the commercial fuel, PWR fuel. So the PWR-based fuel is with slightly changes because they say it's a good load following characteristics, or it is much safer as compared to a conventional light water reactor. Those changes have been made. Otherwise, take it is the same as that of a conventional PWR fuel. Second, with regard to the fuel, I think there was a question that whether the fuel utilization, it is also very close. The size is like, if you take it close to 100 megawatt electric, looking at the burn up and power rating, I say it is very close, slightly lesser as compared to because the full cycle life and the residue of the uranium 235 is almost very close. So I don't think that it is completely different that if you use 1000 SMR versus 100 large PWR. I don't think there is much of a difference. And as I was saying, if you talk about 2,500 gigawatt nuclear, how many large reactors also you count? It will not be 10, 20 what we are talking about. It will be several thousand if we have to reach that target. Thank you.
No, sir, I was not meaning either the cost or the burn-up. I am talking of the availability of fuel for such large-scale consumption.
Okay, actually,
1 minute. And there are kind of international kind of big brother attitude that you cannot have this, you cannot have that. Otherwise, why would NPCIL have to safeguard its commercial reactors? You are using the word commercial time and again. All our reactors are for commercial use, for producing electricity only. Still, we have to safeguard them. So when we have so many SMRs, do you think the big brother would allow it to go scot-free?
Actually, big brothers also are looking for opportunity. It is a global problem. It is not a problem with India. It's a global problem. Everybody has to run into that. Business plus nuclear.
Thank you very much for the interesting debate that we have had in this session. So if there are, there's a question. There one more question.
Hello. This is okay. This was very interesting, and this type of discussion made us think of something else. Something else means India is a position now to lead world to show how nuclear program can be. And we are thinking that others are technology provider. In fact, I think we are the most competent competent country to lead the world for, because constructing, only decommissioning we didn't do. Rest of everything, we are the leaders. Right. We are the longest power production, and we are thinking that our persons are drained. And it is, why called we are drained? We are sending our talented person outside to go to get or utilize their skill properly. Why can't we think of hiring America or Europe person here to do our job? Why we are thinking in the other way? That let us give them some opportunity, let them work here.
I think this will happen by 2050.
I was thinking 5 years before it should happen, but 5 years has crossed, nothing is happening.
No, it will happen.
It should happen, and we should be there. But why we cannot think that we will hire
because
American or European
let
to
me
work
answer
for
in a
us?
very lighter sense. Please don't take it seriously. Just before we break, so let us take it very lighter sense. I started with the word we are riding bicycle. People who are moving in plane, they don't look at bicycle. So moment we also drive aeroplanes, people will come back to us. Thank you.
Thank you. So, okay. There's one more question.
Can I shout?
You don't have to shout.
I'll stand up. It's a very interesting remarks by all the people.
Have it closer.
Okay, closer. Right into the mouth. I would like to just add a few remarks. In fact, I endorse most of the things which has been told. There are more than 30 advantages of SMRs, many issues too, including what Mr. Kakodkar told, transportation of HALEU fuel, which is, as you said, more than normal enrichment to international transport. But the three main reasons is there are 30 to 50 countries who want to start. They can't afford a big reactor. Their grid cannot afford more than 300 megawatts. And they want power within 3 or 4 years. These three reasons are there. Then I also want to endorse something. We must look into not only domestic. Time has come that we grow up much bigger than what domestic industries. In fact, I'm very happy you asked L&T how many they can make. I would like to add how many you can export. So, for example, I probably endorse many of the countries' idea that probably they want to buy from an energy member. But there is no real restriction. But at least, like what we're doing in Rupur plant in VVR, a lot of ECP contracts are being taken. At least for about next 5 to 6 years, there can be a third-party supply. So our industries can master the SMR technology, not only looking into our own requirement, because we are going for bigger reactors also, but see the expert, like what he told, I think we are going to be a big player in this. And I have a feeling that nuclear industry will be almost twice as big as IT industry in the form of getting money from abroad. Thank you.
Thank you, sir. So now with this, we would be moving towards the final round of our discussion, sir. Would you like to have, before we wrap up, would you like to have your concluding
I
remarks?
think I already have spoken my heart to the audience. Only one thing I say, this is again my slogan, that we are talking about tomorrow. Tomorrow, most of us will not be here, let me tell you, by the time this net zero happens. But what is important, we have to change our yesterday's mindset for tomorrow's world. It needs a special purpose vehicle, not with yesterday's technology. And that is where both the researchers, the utilities, and regulators and industries have to think and work. Time is short, and we have to work together for a technology for tomorrow, manufacturing aspects for tomorrow, utilize deployment for tomorrow, not with yesterday's technology. Then this hundreds of gigawatt will not be accomplished. We have to remove zeros, and only that much can happen. This is what is my suggestion to this August audience. Thank you.
Thank you.
My conclusion is that you live and allow others to live. I have seen Tarapur, everybody was happy, but whereas in Kakrapara, when the projects came, many of the people died down because of whatever may be the reason. Because of the competition, they are quoting low, and finally they are not able to execute. And please allow everybody to work with sufficient margins. Ensure that they are also profited reasonably. That is my.
Thank you.
I've said, if we have to be really practical, then this 30 years plan has to be very practical. And that means the first milestone is freezing of the designs. 1 design, 2 designs, 3 designs. From whichever country you get it, a proven design is a necessity. Don't stick to your own one single design. Have multiple designs available to you. Let the industry decide which design they would like to execute, and give them a chance to do this particular thing. Then you will get 3 or 4 designs available to the country, this country, and multiple reactors are then possible. It will also distribute the work to many industries, not sticking to the one industry. Industry who are capable of integrating it, executing it, the complete plant. But they have to have a design available. So our major first milestone in coming 1 or 2 years to freeze the designs.
Thank you, sir. Mr. Ahmed, your final concluding remark.
From an international point of view, I think we as Indians are sometimes too modest. I think we should acknowledge our strengths reasonably, without exaggeration, but acknowledge them. And I think that will give us the confidence to say that what we say happens.
Thank you, sir. Thank you, all the eminent panelists, for your thought-provoking ideas and sharing your experience. Ladies and gentlemen, so with this interesting panel discussion, we are now wrapping up our session, and now we will be moving for our networking reception.